Hello and welcome to our DataPump cross-platform migration hands-on lab. What we are going to do in this lab is we will migrate a non-CDB from Oracle Database 19c directly into a pluggable database in Oracle 23 AI, and we will use a technique called full transportable export-import. This is utilizing DataPump, so it combines transportable table spaces but let DataPump do all the job. Now, in reality, you often have very large databases, and therefore you really can't wait until you copy hundreds of terabytes over, because for the migration of table spaces, we need to set them read-only. In order to decrease this downtime while the table spaces are set to read-only, we will use a technique called RMAN incrementally rolled forward backups, starting with a level 0 backup and then followed by smaller and faster level 1 incremental backups. Now, in order to do this and leverage this and also have a few super cool new features in RMAN being used, we have a new script set called the M5 scripts. So in this lab, you will migrate a database and you will use the new M5 scripts. Now, let me introduce you a little bit to the environment. So, we have a 19c database called FTX, and we will migrate into a pluggable database in CDB 23. And what you see in the entire lab environments is this arrow bar here, where we show you the distinct parts of the migration. So from configuration to level 0, level 1 incremental backups, application outage, final level 1, then the export, final restore, and then the import. So we have different migration techniques. Standard is transportable table spaces, but we will use the second one here, full transportable export import, where DataPump takes care, and we combine this with RMAN incrementally rolled forward backups, and we will utilize the new M5 scripts because they ease your migration quite a lot and automate all the steps, even the read-only setting of table spaces, the par file for DataPump, everything is part of the M5 scripts. Now, after this quick introduction, let me switch to lab number 1. So in lab number 1, we will now initialize the environment. So when you look a little bit to the left on your desktop, then you see the terminal window, and I double click here on the terminal window and enlarge this a little bit. And we have two tabs open, the yellow, which will be my source database, and the blue one, which will be my target environment. Let me just move it over here that I can access it quicker. Depending on the screen you executed, you may also want to zoom in or zoom out in the XTerm. And we do two quick checks up front. We check if the listener is up and running on our source environment. It is, and we will also check which databases are up and running. And for the lab, we will leverage the 19c FTX database, and we will leverage the container database CDB23. So you don't have to create a new database, you will just create later a new pluggable database, because we can't migrate into a CDB, we can only migrate into a PDB. So we are already done with initializing the environment, and we can go on to lab number 2. In lab number 2, we will now check and prepare our source database. So let us switch to the environment at first. FTX, the dot space FTX sets the environment correctly for the FTX database. And one thing, we made a requirement for the M5 scripts based on experience with many customers. We require that you have at least a 1918 RU or newer, and also the data pump bundle patch. So with the O-patch LS patches, we check here, we have the 1921 RU, and we have also the matching data pump bundle patch. That is especially very important when you have complex data types. All the fixes we think are necessary are in 1918 and newer, and since both are cumulative, when you have 1924, 1925, everything required is in there. The minimum requirement for such migrations from the technology is 18C. In 18C, we have introduced new RMAN functionality, but we said, hey, 18C is out of support, so now we are going forward with 19C, and it must be on source 1918 minimum. Let us connect to the source database and do some checks. So a quick check, because another thing which is a requirement, you must have Enterprise Edition, and it's 19C Enterprise Edition, so that's good to know. Let me go forward and do some additional checks. And something to mention here, you see there are 2 lines in my gray box. And as soon as we have more than 1 line, you must add a return. So you must hit once enter or return for the last command to complete. So it's 19C, compatible is set correctly. Let me check also the database character set. Database character set is AL32 UTF-8. With transportable tablespaces, you can't change the database character set. And you can't change the time zone file, at least not to a lower version. So we take note here, this is time zone 32, and the database runs with hopefully no offset. Otherwise, we can change this and alter this, but there's no offset on a DB time zone. So this looks all good. One additional thing we should like to prepare is a streams pool size. By default, the streams pool size is set to 0 as it is here. And based on experience, we know that data pump runs significantly faster if we have a pre-allocated streams pool size. So we set it here to 128 meg. It should be something in between 128 and 256 meg for proper performance. And for the level 1 incremental backups, it's really key that we have block change tracking on. So I changed this here. This will create a bitmap file in the end, and this will allow RMAN during the level 1 backups to directly jump to the blocks which require a backup. In addition, we create a directory on disk, and ideally in reality, this is on a shared NFS, so you can access everything from both sides. From source and target environment. Here I run the migration only on the same environment, so that is not really an issue, but in reality it's ideally on a shared NFS, and I create now the matching directory in the database pointing to that directory on disk. You could also run the entire task with the system user, but we recommend that you create now a migration user. You can clean this up afterwards and give it also the proper privileges like quota unlimited on system. Makes your life much easier. And then we can already exit from SQL Plus, and we are done with lab number 2. In lab number 3, we create now the target environment. So let me check here. This is my CDB environment, 23 AI. And up front, before we really start, we do a few checks and check whether this is Enterprise Edition as well. Transportable Tablespaces would work in theory from Enterprise Edition down to Standard Edition, but we use some RMAN functionality, and this may not be available when you go cross-platform in this environment. So you may make sure that you have Enterprise Edition on source and target. Then we check the compatible setting, and it's on a default, it's 2300. And we check also streams pool size, and your assumption is already correct. This is also 0, the default here, and we want to allocate streams pool size. Let me do this here, of 128 meg in the target environment as well. So this is good now. We can't migrate into the CDB, and this would make no sense, but we need a PDB. So let me create a pluggable database here. We call it Violet. And also, once it is open, we save the state. That means when I restart my CDB, the PDB will open automatically by itself without any extra command. And then we will use OMF. So let me set the db create file dest. It's U02 Aura data. Let me also check the character set of my PDB, and if all goes well, the default in since 19C actually for container databases is AL32 UTF-8. So this is all good, and of course my PDB gets created also with AL32 UTF-8. So let me check the time zone file at first. You remember it was 42 in source, it's 42 in target, and let me also check the DB time zone, and there's no offset, so this looks all very good. Now also in the target database, I need a directory. So it's the same directory on disk, or assume that it's a shared NFS. Now I point to this one here as well, the M5 dir, and then it's a good best practice to analyze the user schemas sys and system beforehand. That basically applies to all migrations you're attempting. We have seen significant performance improvements, and when you would run only a Java dictionary stats, you may not refresh very outdated, very old statistics, because it would tackle only missing statistics and stale statistics. But we have seen in migrations, when we have really old statistics, it gives an extra boost if we refresh them as well. So this will refresh the entire stats in both user schemas. In the instructions, I will then exit from SQL Plus, and then we are already done with lab number 3, and we can advance to lab number 4. In lab number 4, we will now prepare the M5 scripts. So we have stored the M5 scripts on disk already, and we will change now to our directory, the M5 directory we created beforehand, and copy the zip file into this subdirectory, and then we will unzip it and here we go. The most important file at the beginning is the dbmic driver properties, because in the dbmic driver properties, which is in the cmd subdirectory, we will see here all the environment variables being set. We will see also things like data pump tracing, how many parallel workers we'd like to equip, backup destination for RMAN, destination server directories, and so on and so on. So this is all defined, and you can read more in the instructions about it, how to set certain things. What we like to do now is, in the source database, connect to it. And check the table spaces we would like to migrate. Now for transportable table spaces, we can't transport system and sysaux. System and sysaux can't be taken read-only, and so you can't transport it. And we want to make this a simple and quick exercise, so there's only one table space. But in reality, of course, this will be dozens or hundreds of table spaces depending on your environments. And what we're going to do is after I exit SQL Plus, we will now add, let me just quickly exit SQL Plus, and we will add this users table space into a list file of table spaces. So dbmic ts list txt, list the table spaces separated by commas. Here it's only one single one, so I add this to the file. And this is basically everything I need to prepare. So we are done with lab number 4, and we can advance to lab number 5. In lab number 5, we will now kick off the RMAN level 0 backup. So again, I need to connect to my FTX database. Or set the environment correctly for my FTX database. And then we have a script dbmic driver m5sh, which is in the directory where we unzip the files into, and we call it with L0. So this L0 now will trigger an RMAN level 0 backup of the users table space. And you will see the users table space is not very big. So this will supposedly finish very quickly. Here we are already. It has done a level 0 backup, and 62 megabytes is the table space, and it generates 60 megabyte output file. So level 0 backup basically has the same size more or less than the original files. Let me quickly check here in the command directory what we created. So we have the backup level 01, we have the TS list and the driver properties, and I have also a restore file. Now, since I have this on NFS shared, I can execute that for restoration from my target environment later on. Let's have a quick look into the backup level 01, because then I would like to show you what's the special part here is. First of all, we support now section size backups, and this is the table spaces. So if you have more table spaces, this is then a longer list of table spaces we see here. There's also a log directory. And in a log directory, we find all the information. And this is also where we may want to do a quick check afterwards and see if we found any errors. We do this in a later stage of the lab. What else is there? We have where the backups actually are stored. So this is again on my shared NFS, makes my life much easier. So here's the level 0 backup. You see it's like 50 and a bit megabytes. And with that, I can now initialize the restore. So let me go to my target environment. It generated a restore script. So let me go to the target environment, to the blue one. And here I can see the same thing. So I have the restore script in access. Wonderful. In the CMD subdirectory. Let's do a quick check what's in that file. And here the magic is basically this line here, restore all foreign data files to new from backup set, because this is the magic it does. Here in my case, we go Linux to Linux, so there's no cross-platform, no cross-NDNS, but in reality, this will do the entire job for you and ease your life a lot. So let me now restore the level 0 backup. And it will take a little bit. restore all foreign data files to new from backup set, and here it is done already. So it has completed its job, went very fast. This file does not belong to my database yet. It is just stored on disk. And the idea is now, let's have a quick look. Once you've done that, let's have a quick check on the log files. If we find anything worn or aura in there, and there's nothing to worry about. So we are basically done with lab number 5. In lab number 6, we will start now with the incremental level 1 backups. So I go back to my source environment. And on my source environment, the yellow environment here, I will call again in the FTX environment now the dbmic driver script, but now with L1. So you see L1 here. And the level 1 backup, of course, it's super small because there's no load on my system. But in reality, the idea is you run repeatedly level 1 backups, and the more often you run them, you increase the frequency, the smaller they'll become. Let me list the backup set. Okay, and we see this also from the target environment. Let me just leave the log file here, the log directory, and go into CMD. And we see them here as well. We can do a quick cut. To see what happened. So again, section size, table space users, but in this case, 2-1. So the level 1 backup is done. And now we have also, in the same directory, a restore script. And this is what I'm going to use now. Let's have a quick look into the restore script as well. And the restore script again will now restore to 1 and restore all foreign data files. And let me kick it off. Already done. It was super small and so could work very quickly. Nothing special there. Now, what happened in the background is that this incremental backup got merged into the existing level 01. So there's a rolling forward merge. Final check is, let us check here quickly that there's no errors and no warnings and the log file is clean. So this is all good. Now we would like to make some changes to the source database because we would like to make this a bit more realistic and see some changes really in the environment happening. And then later on we can query that. So I connect to my source database FTX and I create a table here in the FTX database. We have pre-populated with some Formula 1 racing data data set, and we created now this fresh table exit SQL plus, and we perform now another level 1 backup. So let me move in here, task number 3, call the dbmic driver M5 SH with L1. And now you see it's a little bit bigger than the previous one. It has now 20 megabytes. So there were a few changes. And I will restore it. Since I'm on the same server, I could execute the restore also on the source environment. I will do it from the target environment here. Go to the cmd command window and run my restore script from there. And this will now take a little bit longer, but you see it's also super fast because the files are really, really small. Final check. Let me check if there's any errors in the file. No errors. That looks really good. So we are done with lab number 6, and then we can advance to lab number 7. In lab number 7, I would like to do now a test migration. The point is that transportable tablespaces requires a read-only time. Now, you could say, oh, we hope that all goes well, but the key to a successful large transportable tablespace migration is also that you are able to have like a dry run, which requires still outage on the production side. And this is what we are going to do here. So what we want to do is we have allocated an outage, maybe on the weekend, at least for a little bit, to take the table spaces read-only. And what we want to do here is we go to the source environment again. And on the source environment, in the M5 directory, we call now again our driver script, but with a new command option with L1F. So L1F now triggers the final incremental backup. And this L1F will do something in our database. It will switch the user's table space to read-only. But since we put in an extra security layer that nobody calls it accidentally, it is a password protected thing. And you see here there's a password on the system user. It's called FTX user here. And I have to put that in. And once I put it in, it will now change the table spaces, or in my case, one table space to read only, and take the final level 1 incremental backup. In parallel, it will also, as soon as the table space is read only, start a full transportable export. So you recognize you didn't have to create any sort of par files. We do this for you, and the par file creation is sourced from information we put into the properties file at the beginning. So we are done. You see the file has about 20 megabytes. It leaves the table space in read-only mode. So since this is a test run, we quickly, once this has ended, should switch the table space or table spaces again into read-write mode to avoid any sort of problems. But we needed an outage in order to test the full process. I can exit SQL+. And again, go to my target environment. Into the M5 directory and kick off the restore. This is now the restore, which makes it a complete backup. So from there on, we can go forward. And what I'm going to do is now the transportable import. And again, we protect here. We would like to have the password. Let's go to the instructions. The password here is Oracle. Now we import into the pluggable database and run the full transportable import into it. It's already done. And we use the parameter here. It's called transportable keep read only. So this does not switch the files of the table spaces into read-write mode. By default, the table spaces will be switched to read-write. This prevents it. And so we can easily reuse these files. This is just meant for testing, but this is actually what we wanted to do here. Let me now advance to lab number 8. Oh, this is what we want to do here. Let us now check the database. So in my 23C environment, I connect to my container Violet. And here we have the tables, and we have also the table we created beforehand. We find the lab times, and we find the lab times backup. The lab times backup is the table we created in lab number 6. And of course we can query both of them, which we did. Now, when I try to change now something in the database, I can query, but you remember the table space is still not read-write. I can't create a table. The table space users is still read-only. I can't allocate space in it. That makes a lot of sense. And we are going to change now the root container. And we restart our test environment here quickly. But only in mount status. The import driver script is so smart, it even created a guaranteed restore point. And once I'm done, the flashback is very fast. I open my database again, and I have to open it after that flashback operation with reset logs. And let us quickly check the Violet PDB and whether the lab time backup table exists. It does not. Which is expected. Nothing is plugged in here. No rows. Of course, we use flashback. So let us exit from SQL Plus here. And go back to the source environment. And in the source environment, once we connect it to the database, I would like to create another copy. Not backup, but backup 2 of this table. And exit SQL Plus again. Let us now perform just another incremental backup. We can do that. Should be again about 40 megabytes now with the 2 changes in it. And also restore that incremental backup on my target environment. So I basically went back from doing a test level 1 final to the regular level 1 backups. Again, just on the side, if you want to see the output, you always can go to this small tiny little arrow and see the output we expected. And final check is we again check the log file. So no errors, no Aura errors. This looks very good. And we are done with lab number 7 with the test migration. Let me proceed now with the lab number 8, the final preparations. And for the final preparations, we would like to export the statistics because we want to move our stats. So I'm connecting again to my source environment here. And in the source environment, I create now a test user for the statistics move and alter this user. Again, now with quota on the table space. And I created a user with no authentication. It's just a schema. I would like to create now with the DBMS stats package a staging table in the user's table space. And export the statistics of the schema F1 into this staging table. Why are we doing this? Because it's much quicker to move the statistics via staging table than let it happen during the import. Again, since I did some changes and since we are approaching now the live migration, I will regather stats also on the source side, just again on sys and system. So statistics have been regathered. We can exit SQL Plus. And then we are done with the prep steps for the live migration. Let's complete now the real migration. So now we have a real outage. It's not just a test outage, we have a real outage. Then we will do the final backup and the export and the final restore and then the import, but not just for test now. Now we do it for real. So in my source environment, I trigger now the L1F the final incremental backup. And again, you remember, we need a password. I think it was ftx user. It is. So it switched now the table space into read-only mode again. And it took the level 1 final incremental backup, and it triggers now the data pump full transportable export. So we are done. The L1F and the export is done. Now we need to restore the backup on the target environment. The final one. And again, this will proceed very, very quickly. It's already done. What we miss now is the data pump import. So let us quickly examine the driver script. We're using in this case. And we see what it does here. So this is the driver script. It sets the environments correctly and the connect string into our violet here. Our data pump directory is m5dir parallel 4 because in 23AI we have parallel metadata and there's no tracing enabled. All good. We just need to kick it off. And you remember we will need a password here as well. The instructions tell you here, start the import driver script. It fails, but informs you to add additional information. Let's give this a try. And let's have it fail. So I just start the driver script. It is, please call this script. And here it gives you an example, the RMAN restore log, read only, test only, and so on. So back to the instructions. We need to collect the information for the script. And here we have it. So we have the dump file and we have the log file, the L1F. Have it set in the environment. And we want test no here. And so let's do that. So what has it done? Start the import driver script in test mode. And this simply generates the parameter file. Let us examine the parameter file. And this is now a complete data pump parameter file with the user ID, dump file, directory, log time all, trace 0, parallel 4, matrix yes, and of course the transportable data file. And with that, instead of saying test equals n, now I say run, and this will now run my full transportable import. Again, as you remember, we need a password, and the password here is Oracle. And we are already done. So this would be the output. We have seen this on screen. And we can advance now to the final lab. In lab number 10, we do now the post-migration tasks. So let us connect to the database, or to be more precise, to the pluggable database. So this is my CDB23 environment, and I connect to Violet. And then, since we imported now a lot of information into the dictionary, we would like to refresh again the stats for sys and system. So we are done with the stats creation. Next step is we would like to also now unfold the stats. We moved over, you remember, we wrote the stats table into the users table space. So the staging table doesn't need to be exported separately. We just need to unload the statistics from the staging table. And you see, this is super fast. So please take this as a best practice. Always move the stats this way. And verify that there are no statistics on the F1 schema. Let us see that quickly. Yeah, and you see number of rows and last analyzed is all empty because we didn't move it over for this. So now we would like to import the statistics on the F1 schema. As you saw, there are no stats on it. And quickly check if that completed successfully. And here we are. So stats are now there. Perfect. And don't forget to drop the user. We don't need that user anymore. This was just a stats transportation user, our vehicle. So user is gone. Always clean up and check the final migration stage. So let's see if the two backup tables have data, and they have data. The first one, the second one, both identical. And additional tasks is exit SQL plus and stop our source environment. So exit here. We're almost done. We don't want to have changes now. The table space, the users table space is still read-only. So hopefully we have not seen any sort of changes. We could have shut it down also earlier, of course. So source database is going down, can be decommissioned now. And congratulations, you have used the M5 scripts to migrate a complete database. You have done it all. Thank you very much. And now go forward and do your own.